What's going on again, Linear Algebros? It's Mr. C here, and we're going to polish off the rest of section 4.6, where we're going to look at a quick and efficient method for computing transition matrices in n-space. So it just boils down to two steps. Step one, we want to form an augmented matrix with the basis vectors from B prime on the left of the vertical bar and the basis vectors of B on the right of the vertical bar. And then what we want to do is use elementary row operations to reduce the matrix in step one to reduce row echelon form, thereby obtaining the identity on the left, and the numbers that are on the right of the vertical bar will be the entries of the transition matrix from B to B prime. Now, of course, if we wanted the other transition matrix, B prime to B, we just switch around the matrices, or we could first find this one and find its inverse. So we have an example illustrating this procedure. These basis vectors are going to come from R3. The basis vectors U1, U2, and U3 are basis vectors for the basis B. Just want to note that. And then these basis vectors, U1 prime, U2 prime, U3 prime, will be the basis vectors for B prime. And in part A, we want to compute the transition matrix, which takes us from the basis B to the basis B prime. And underneath there, I have something that should make this a little easier on the eyes, or at least help us to understand the concept a little better. If we want to go from the basis B to the basis B prime, let's imagine the basis B is like an old basis, and the basis B prime is like a new basis. So it kind of gets flip-flopped in here, but on the left you want the vectors from the new basis, and on the right you want the vectors from the old basis. Now when we reduce this so that we get the identity on the left-hand side, those steps that help us to turn the new basis vectors into the identity will be applied to these basis vectors, thereby giving us the necessary transition matrix entries. So below this I have the matrix populated. Column 1 on the left is from the entries of U1 prime. Column 2 is from U2 prime, and then column 3 is from U3 prime. So these are the new basis vectors that I've populated on the left. And similarly, I have the entries on the right of the vertical bar populated. The first column comes from the first basis vector U1, the second from U2, and the third from U3. What you want to do is, probably just to save some time, is enter this into your calculator, this augmented matrix, and you'd basically be defining a 3 by 6, and you'd go ahead and enter all the entries in row 1 as this, all the entries in row 2 as these guys, and then all the entries in row 3 as the bottom row. And then simply use the RREF function in the graphing calculator, and you'll see that the first 3 columns resemble the columns of the 3 by 3 identity. And then the numbers on the right are actually going to be the entries of the transition matrix, which takes us from B to B prime. It's very much like the parallels method. So anyway, once you have the identity on the left and these entries on the right, you can go ahead and just kind of pluck them out and say that, well, hey, my transition matrix from B to B prime is exactly equal to a 3 by 3 with those entries that were to the right of the vertical bar. Alright, so this is the matrix that would take us from the basis B to B prime. The second part, and the last thing for the section 4.6 note packet, is to utilize this transition matrix in order for us to compute the vector W's components with respect to B prime. Here they give us a vector W. Its entries are -5, 8, and -5. And just like with the last video, you want to assume that this is in terms of I, J, and K. So the way it's provided to us isn't necessarily the components of W with respect to B prime. And for that reason, I'm just going to go ahead and indicate that this is actually with respect to I, J, and K, just so that we're really clear on that. So this part requires a couple of calculations. The first is, let's see what the components of W are with respect to the old basis B. And so a very familiar linear combination setup. How much of the basis vector u1 do we need, how much of u2, and how much of u3 do we need in order to get these components -5, 8, and -5. So it throws you into a matrix equation. And the coefficient matrix, you'll notice the column 1 are the entries of u1, column 2 are the entries of u2, and then column 3 contains the entries of u3. And solving for C1, C2, and C3, we actually get some nice entries this time. You need one copy of U1, so C1 equals 1. C2 equals 1 as well, means you need one copy of U2. And this tells us that C3 is equal to 1 as well, so you would just need one copy of C3. And you could quickly check that actually if all these coefficients or if all these coefficients were 1s and you combined all three of these vectors together, you actually would get the entries -5, 8, and -5. Alright, but anyway, what this vector is it's the vector W with respect to the basis B. Now why do we need that? Well, it's going to help us in conjunction with the transition matrix to figure out the components of W with respect to B prime. So to that end, to figure out the components of W with respect to B prime, we take the transition matrix that we figured out from part A and we multiply it to the vector we just got in step 1 of the solution. Alright, so there they are, the matrices that correspond to each of those. And when you multiply these together, you don't get very nice entries this time, unfortunately, but they are what they are. First entry is 19 twelfths, second is -43 twelfths, and then third is 4 thirds. Alright, and these would be the components of the vector W with respect to the basis vectors from B prime. You could check this work by writing out the vector W with respect to I, J, and K as a linear combination of the basis vectors from B prime and then solving the system that way. But I think, we put all that hard work into finding the transition matrix, so therefore we should go ahead and actually use it. Alright, and here's an example of how you do that. So that about wraps it up for the notes for section 4.6. Thanks for watching, and I'll be happy to answer any questions you have via email or in class. Thanks again, guys.